In this video, we are going to use graphing to determine a solution for a system of equations. So what we're going to do is graph both equations, first one, then the other. We have to determine whether the lines intersect, are parallel, or are the same line. Those are the three things that could possibly happen with systems of equations. In this course, we're generally just going to be talking about two equations. If the lines intersect, there is a point of intersection that is the one and only solution to the system. If the lines are parallel, the system has no solution. You're going to get something weird like we had seen before where -3 equals -5. You know it's not true. That's where you're going to have no solution. That means the lines are parallel, they never cross. You might come across time where the lines are the same line and there's an infinite number of solutions. When you see this, you're going to see something like 0 equals 0 or 12 equals 12. Anything where that is absolutely true but is not giving you any information about a variable. I mean, this is true. I mean, this is also true, but it means that there are an infinite number of solutions because they are the same line. Once you've figured out a solution, assuming that there is one, just check the solution in both equations at the very end. We're going to do we'll do about 4 examples together before I have you work on your own. So solve the system by graphing. The way I like to do these is I like using the intercepts. I will plug, so I'm going to do my first line in red. It's just the easiest way to go about this. I'm going to put 0 in for x, then I just get y equals 7. Then I'm going to plug 0 in for y, and I get 2x equals 7, divide both sides by 2, x equals 7 halves, or x equals 3.5. We'll look at the other one. We'll do another t-table, x and y. I'm going to do the same thing. X equals 0, I get -2y equals 6, divide both sides by -2, I get y equals -3. If I put in y equals 0, I get x equals 6. So now we're going to graph these. You only need 2 points to graph, so you should be good to go at this point. Especially if you are using the intercepts, like I highly recommend, that you are less likely to mess up anything if you do it this way. So x is 0, y is 1, 2, 3, 4, 5, 6, 7. X is 3.5, 1, 2, 3.5 is about here. Then you'll draw your line as straight as you can. Just connect those two dots. And again, I'm using my writing tablet. I am not used to it. Okay, that's almost a line. Get rid of this. Get rid of that. So your lines are going to be better because you're most likely not using a drawing tablet for the first time like I am. So let's look at x is 0, y is -3. 1, 2, 3. X is 0, y is -3. Here, x is 6, 1, 2, 3, 4, 5, 6. There's our line. Look at me, I'm actually drawing a line. All right, that's like not horribly bad. So it looks as if our lines intersect here at 1, 2, 3, 4, -1. So let's try plugging that in. I mean, my line is not the straightest thing in the entire world, So, I mean, it's one of the reasons why this isn't necessarily the best way to do this, but we'll try it. Goodness. So we're going to plug 4 in for x. Two times 4 is 8 minus 1 equals 7. That is true. So it's good for the first one. Let's plug it into the second one. X is 4 minus 2 times negative 1 equals 6. 2 times negative 1 is negative 2. That makes this a plus. So this one checks out. So let's take a look at this example. Do the first one green this time. So again, we are going to be looking at the x and y intercepts. So let's plug 0 in for x, and we get y equals negative 1. If we plug 0 in for y, we get 3x equals negative 1. Divide both sides by 3, and we get negative 1/3. Let's do the same thing with the second line. X and y. X is 0, y is 0. If y is 0, looks like x is 0, right? If y is 0, we get 2x equals 0. Divide both sides by 2, x equals 0. That's not helpful. So we'll have to pick another number to throw in there. Let's put x equals 1 in there. So then we'll have 2 times 1 plus y equals 0. This turns into 2. We'll subtract 2 from both sides, and y equals negative 2. There, that's more helpful, right? So let's try to graph this. So we have x is 0, y is negative 1. X is negative 1/3, y is 0. It's going to be kind of a cruddy line. I'm thinking we should probably try putting something else in here. Negative 1/3 is not very conducive to a good graph. So let's put something else in there. So we're not going to use that. Not going to use y equals 0. What could we put in here? How about y equals negative 2? Or positive 2. So if y is positive 2, we'll subtract 2 from both sides. 3x equals negative 3. Divide both sides by 3. We get x equals negative 1. There, that's a little bit easier to graph. So we have x is negative 1, y is 2, and that's much better. We can make a better line with that, I think. Now the question is, will my wrist allow me to? Having huge issues with this. I'm going to try using my mouse instead. There, that's a little better. All right, there's our green line. Let's draw our red line. Hopefully it won't be so challenging for me. So we have 0, 0. Note the line is not crossing there. We have 1, negative 2. So I'm going to do this with my mouse as well. All right, let's see how we did. It looks like, according to my horribly drawn graph, we might be crossing here at negative 1, 2. We already put that into our first equation, so let's try putting it into our second equation. So x is negative 1. Y is 2 equals 0. Negative 2 plus 2 equals 0, and this is true. So that is indeed our solution. Let's look at this one. First equation I will do in red this time. Do x is 0, throw 0 in there, we get y equals negative 3. If we do y is 0, what do we get for x? Add 3 to both sides. Multiply both sides by 2. X equals 6. So those are two good points for us to use. Let's look at the second equation. If we want x equals 0, y is going to be negative 2, y equals 4, divide both sides by negative 2, and we get 4 divided by negative 2 is negative 2. If we put 0 in for y, we get x equals 4. So let's graph that. X is 0, y is negative 2. X is 4, y is 0. Grab my red. Oh, I suppose I should actually attempt a line. This is the part that makes me nervous, because it always looks terrible. Okay. Okay, we got one line down. Let's look at the other one. So, x is 0, y is negative 3. Y is 0, x is 6. We will attempt, and it looks like these lines are parallel. So this one has no solution. All right, last example. Let's look at number 4. Do the first equation in red. Do our normal thing that we do. x, y, x equals 0, y equals negative 3, y equals 0, we'll add 3 to both sides, and x equals 3 halves. Or 1.5. Now let's look at our other equation. Put 0 in for x, we get 3y equals negative 9. Divide both sides by 3, we get y equals negative 3. Put y in as 0, we get negative 6x equals negative 9. Divide both sides by negative 6, and we get 1.5. Well, we can already see these points match exactly. These points match exactly. We have the same line. We don't even have to graph it. Just seeing that, you have to verify that 2 points at least are exactly the same, and you can say it's the same line. If they share 1 point, it means that they could just be crossing at that 1 point. You have to verify that at least 2 are the same. So there are infinite solutions. All right, go ahead and give this a go on problem 18, and we'll look at some other strategies in future videos.